needs their battle to destroy the evil forces of the Decepticons, the Transformers. Robots in disguise, the Transformers. More than meets the eye, the Transformers.
In section 9A, transformations, our goal is to be able to solve problems involving symmetry and transformation. We will be able to determine whether a figure is symmetric with respect to a line or a point. We will be able to determine whether a figure has been translated, reflected, rotated, or dilated using coordinate methods. We've already studied dilations earlier, so today we're just going to focus on isometric transformations. A transformation occurs when a figure changes or moves. The figure before the change is called the pre-image. Pre, remember, means before, so that's the image before we move it. The figure after the change is the image, what we see after. For example, you look in the mirror, you see your image. That's your reflection. A figure that does not change size or shape is called an isometry. And today we're going to focus on the isometric transformations called translations, reflections, and rotations. Let's begin with line reflection. Line reflection is the mirror image of the figure over a line. That line is called the line of reflection. Notice in this picture we have the pre-image. The points are labeled A, B, and C, the vertices of the triangle. This is triangle ABC, the pre-image, before it has been reflected. Here's the line of reflection, and then the image. Think about looking in a mirror. The line of reflection is kind of like the mirror line. So imagine this is you standing in front of your mirror. This would be like the mirror, the line of reflection, and what you see is your image. And the way we label those points is with the primes, A prime, B prime, C prime. So this would be triangle A prime, B prime, C prime. So remember, the way that we say that is A prime, B prime, C prime. So wherever A is, however far it is away from the mirror line, the line of reflection, A prime is the exact same amount away in the opposite direction. Similarly, here's point C. See how far it is away from that mirror line? Point C prime, the exact amount away in the opposite direction. Now, mostly what you're going to ask to do is to reflect something over a line in a coordinate plane, such as the line we're given here, y equals x. Think about how you graph y equals x, starting at the origin, and then the slope is 1. So up 1 over 1, up 1 over 1. It's that diagonal line that you see as I start to plot those points. So we're going to connect those points to make that mirror line or that line of reflection. So there's that line, y equals x. That's our mirror line or our line of reflection. So now as our mirror line, our line of reflection is slanted, it's a little bit trickier than when it's straight up and down and we just say left or right. Left and right are opposites. Well, if we're reflecting over the line y equals x, that means that the x and y will switch. Well, what does that mean? Well, look at where this top point of the quadrilateral is, and let's count how many spaces it is away from our line of reflection. Now, which way should I go? Doesn't really matter as long as we think about what we're going to switch. So, for example, I'm going to count 1, 2, 3, 4 spaces in the x direction. So if I'm going to flip that over the line y equals x, I'm switching the x and the y. So that means I'm going to count 4 spaces in the y direction. Remember where your axes are. This is the x-axis, this is the y-axis. So if I go 4 places in the x direction, switch it to go 4 in the y direction. So that's going to be 1, 2, 3, 4 in the y direction, and that's where I'm going to land for the reflection, the image of this top point of the quadrilateral. Let's continue to count that way for the other 3 points. This point right here, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9 to get straight to that line of reflection. So 9 in that direction. Let's do 9 in the opposite direction, in the y direction. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I counted 9 in this direction, and there's my other point. So this one was 9 in that direction, just like this one was 4 in that opposite direction. Let's count the other 2 points. That looks like 6, so I'm going to count 6 in the y direction. 1, 2, 3, 4, 5, 6. And then finally, I'm going to count from this point. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, 9. And so from the place where I stopped, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we'll land right there. So now let's connect those points to get our image. And there's the image of our quadrilateral down here. Imagine, maybe turn your head to the right and imagine flipping this quadrilateral over this line of reflection, and where does it land?